So this is the same idea. We want to eventually find all of our zeros, but we're going to use synthetic division. So I know my first zero is that x equals minus 2i, and my next zero is x equals 1 plus 2i. I'm going to need to take these out using synthetic division. I would not suggest doing long division when I have that complex version. Go ahead. This is going to be all calculator active like I said. Get this guy into y1. When we set up our synthetic division, it's going to be 1 minus 2i because the 0 goes in there, and you're going to write your coefficients across the top. Don't forget your placeholder. This is normal synthetic division for us. We're going to bring down the 4, and the first thing we're going to do is 4 times 1 minus 2i. So what I usually do is I'm going to type it in exactly like this. Get my product, get my answer, and it's 4 minus 8i. 4 minus 8i. I need to add 0 to that, plus 0. Should be the same, but kind of as we're going through this process, I want it to stay all of that. The next thing we're going to have is this times this. So 1 minus 2i times 4 minus 8i. Should be a mess. It's negative 12 minus 16i. I need to add 17 to that, so I can just say plus 17. It pulls my answer from the last line. So now I have 5 minus 16i. So now I need 5 minus 16i times 1 minus 2i. So 5 minus 16i times 1 minus 2i. And that answer is negative 27 minus 26i. Negative 27 minus 26i. I need to add 14 to that. Remember, this is synthetic division, which gives me negative 13 minus 26i. We're going to multiply that back by that known 0. So zoom out for a second. So this times this. So we have negative 13 minus 26i. Times 1 minus 2i. And that is equal to negative 65. When you add those, you get 0. This kind of does two things for us. It proves that yes, it is a factor, and confirms that our math is right, which is what we want. Now, 1 plus 2i comes out. All of these, you should start to see a lot of your i's disappear. If your i's are not disappearing when you take out that second known 0, that means that there is a math mistake somewhere. 4 drops down. So we're going to have 4 times 1 plus 2i. And we get 4 plus 8i. 4 plus 8i. We want to add to that 4 plus 8i. So my red is what I have in my calculator. I'm going to add the black to it, which is 4 minus 8i. You could probably also do this in your head, but this is calculator active, so make sure you're kind of checking your work. 8. 8 times 1 plus 2i. And I get 8 plus 16i. Okay. What you want to be checking is that those i's are going to cancel, and they're going to. So 8 plus 16i, the red is what I have sitting there, so I'm going to add the black, which is 5 minus 16i. And you get 13. And we have 13 times 1 plus 2i. What we're looking for is we want to see basically that same exact, the opposite of what we have. So 13 plus 26i, that's exactly what we want to see. Negative 13 plus 13 is 0. Negative 26i plus 26i is 0. So that's confirming that we did our math correctly, and that is in fact another factor. So now we have a nice quadratic quotient left, 4x squared plus 8x plus 13. So I'm going to use the quadratic formula. X is going to be equal to negative 8 plus or minus, let's see here, 64 minus the quantity 4 times 13, all over 8. So you're going to have negative 8 plus or minus radical negative 144 all over 8, negative 8 plus or minus 12i all over 8, negative 8, oh, sorry, I'm going to take that out, so that's going to turn into negative 1 plus or minus 4/3 I, which is exactly what we got with the other method that I did in the previous example. So x equals 1 minus 2i, x equals 1 plus 2i, x equals negative 1 plus 4/3 I, and then kind of squeeze this guy, negative 1 minus 4/3 I. You are supposed to do the linear factorization for this problem, so that's kind of our last step that we need to worry about. First two shouldn't be too bad. This one I'm going to multiply everything by 3, so 3x minus 3 plus 4i. I'm sorry, 3x equals negative 3 plus 4i. Then move everything to the other side, so 3x plus 3 minus 4i. Same with this one, multiply everything by 3. And then move it to the other side. So this is going to be 3x plus 3 minus 4i, 3x plus 3 plus 4i. Linear factorization. The idea that you should kind of be picking up on this, complex 0, and then when we factored those guys out using synthetic division, another complex 0, another complex 0. So you have this 4th degree polynomial, 4 zeros, 4 roots, 4 answers, 4 solutions, no x-intercepts. Looks something like that. So he's never going to come down and actually touch that x-axis, but we would say, yeah, he really does have 4 answers. He really does have 4 solutions, 4 roots, 4 zeros. He doesn't have any x-intercepts. So it's using that fundamental theorem of algebra from yesterday.